Hi everyone, welcome to a brand new module. We are now in Module 2. We are in Topic 1, Lesson 1. So Module 2, Topic 1, Lesson 1. It's all relative. So it's an introduction to ratios. And I know a lot of you have already been doing ratios and Mathia, so hopefully if you're struggling on that part, hopefully this will all kind of come together and make sense for you. Okay, so our learning goals are our objectives here. Distinguish between something called additive and multiplicative relationships between two quantities. Understand the concept of a ratio. Write ratios in different forms and use ratio language to represent relationships between two quantities. Distinguish between part-to-part and part-to-whole ratios. Understand that percents are part-to-whole ratios between a quantity and 100. Our key terms: additive reasoning, multiplicative reasoning, ratio, and percent. Okay, so our quick little warm up, our little do now here, our review. Answer each question. Laquan put $15 in savings this week. This was $3 more than the amount he put in savings last week. How much did he put in savings last week? So he put $15 in savings this week, which was $3 more than what he did last week. So how much did he put in this week? So what do you think? I want you to pause the video, and I know some of you actually do, and for those who do that, I greatly appreciate it. I've heard some of you saying that in class. She told you to pause, so go ahead and pause, see if you can get that written down. Also try the other one. Joanne bought 3 times as many books as Mitchell at the book fair. If Mitchell bought 5 books, how many books did Joanne buy? Right there's your clue right there, 3 times. Okay, so you probably can just figure it out just thinking about it with some logic. So if Laquan put $15 in this week and it was $3 more than last week, it's a way of saying that this week is $3 less than last week. So 15 minus 3 is going to be 12. So $12. So we had whatever last week's amount was. So I'm going to say W for week. Whatever that amount was plus 3 gave us what he made this week, 15. So what plus 3 is 15? 12. Okay, Joanne bought 3 times as many books as Mitchell at the book fair. 3 times is literally 3 times something. As many books as Mitchell at the book fair. If Mitchell bought 5 books, how many books did Joanne buy? So 3 times the amount Mitchell bought, which was 5 books. So 3 times 5 books equals the amount Mitchell bought, which is, oops, not a dollar sign. It's a number of books. 15 books. Okay, pause if you need to write that down. It says you know how to make additive and multiplicative comparisons. You can answer questions like, if Johnny has 6 apples and Susie has 12 apples, who has more apples? So this one we can do in either multiplicative or additive, and we'll get into that a little bit more. Turning the page. Predict the score. The Crusaders and the Blue Jays just finished the first half of their basketball game. I'm sorry, this is on page 170. I should have told you that right in the beginning. This one was page 169. Hopefully you had that. Okay, so it says to predict the final score. So you're going to pause and put down what you think it's going to be. Explain what your reasoning is. So the Crusaders at halftime have 30 and the Blue Jays have 20. So it says predict what they will have at the end. Can you hear my cat meowing? That's Lily. She's a pain. Get down, girl. Thanks. Okay, I'm going to pause while you pause, and I'll be right back. Okay, well, since I can't hear what you thought, I don't have any way for you to explain your reasoning to me. we're going to move on to the next page, on to page 171, and look at what two students here, Robina, and Aaron, each predicted the final score of a basketball game between the Crusaders and the Blue Jays. So I'm wondering if your predictions match theirs. So Robina said, well, if the halftime score was Crusaders 30 and Blue Jays 20, she said the final score 60 and 40. I think the final score will be double the score at halftime. So she took each of these and she multiplied by 2 to double it. So 30 times 2 equals 60, 20 times 2 equals 40. And then Aaron says, I think the Crusaders will play hard enough to stay 10 points ahead of the Blue Jays. So if they were 10 points ahead here, like these guys were 10 more than them, so you had to add 10 to their score. And then, so it looks like she thinks like they will increase 20 points. So looks like she's adding 20. And if she adds 20 here, then that increases both of their scores, and these guys still remain 10 points ahead. So by adding 20 to both, it kept the final score with a separation of 10 in between. Okay, then letter A says to describe the reasoning that they each use to make the statement. So Robina did what? She doubled the score. She doubled each score. Okay, and what did Aaron do? So Aaron added 20 to each score. So it looks like she thought the Blue Jays would double what their score was, right? Because really that is doubling it there. But to maintain that 10 points distance, she had to also add 20 here. So based on the two predictions, which team scored more points in the second half? So let's see. So for the Crusaders and Blue Jays, I'm going to write it like this. And then we're going to say this is Robina. And then we'll put Aaron right here. So in the second half, Robina thought that they scored how many points? If they did 30 points in the first half and they had a final score of 60, then in the second half, they must have scored 30 points. And what about the Blue Jays? If they have 20 in the first and then 40, they must have scored 20 points. And then what about Aaron's? So if they were at 30 and now they're at 50, they scored 20 points. And then for the Blue Jays, they were at 20 and now they're at 40. They also scored 20 points. So for Rabina, she would say the Crusaders scored more in the second half, and Aaron would say neither did. It was literally a tie. They both scored 20 points. Okay, pause if you need to, as I'm going to move on. Flipping the page to 172. So this is page 172. I'll just write that up here. I don't know why the lighting keeps going in and out like that. I apologize for that. One of the students used additive reasoning to make her comparison, and the other used multiplicative reasoning. Additive reasoning focuses on the use of addition and subtraction for comparisons. Focuses on addition and subtraction. And multiplicative reasoning focuses on the use of multiplication and division. Which student used additive reasoning and which used multiplicative? So that is going back to this one. So who multiplied to get theirs and who added? So it looks like Robina used multiplicative. I'm just going to go here, Robina. And then Erin added 20 to each. So Erin used additive reasoning. Okay, next one. Read the age scenario and answer each question. Vicki and her nephew Benjamin share the same birthday. They were both born on March 4th. Today I'm 40 years old and you're 10. I'm 4 times as old as you are. Benjamin says, wow, you're old. Vicki says, yeah, but in 5 years I'll be 45 and you'll be 15. Then I will only be 3 times as old as you. And he says, I'm catching up to you. Vicki goes on and says, and 15 years after that, I'll be 60 and you'll be 30. Then I'll only be twice as old as you. Benjamin says, in enough time, I'll be older than you, Aunt Vicki. Is Vicki correct about how their ages change? Is Benjamin correct in thinking that he will eventually be older than his aunt? Okay, I want you to pause and I want you to think about that. Okay, well, let's think this through here a bit. Okay, so is Vicki correct about their ages, and is Ben correct in thinking that he'll eventually be older? So if we have like the starting time of now, and then we talk about their ages in 5 years from now, and then it tells us 15 years. And if we have Ben here, and then we put Vicki's age here. So this is what Vicki is saying. She's saying she's 40 years old now, and Ben is 10. And she's saying she's 4 times as old. Okay, that works, 4 times. And then says in 5 years, I will be 45. Okay, sorry about that. I had to pause for a moment. Not really sure where I was at. Somebody walked in the room. So, pick this back up. So, Vicki is saying she's 4 times older, which is true. 10 times 4 gives you Vicki's age. In 5 years, she says, I'll be 45 and he'll be 15. And she says, I'll be 3 times as old as you. And again, that works as well. And 15 years after that, so 15 years after 45, so 15 years after 45, she'll be 60, which is correct. That's what she said. 15 years later, because he'll be 30, and that's correct. So that was 5 years later and 15 years later. But she says, I'll be twice as old as you. So that is correct, but is she correct about how their ages change? So what's actually happening with their ages? If it can't be a multiplicative reasoning, a multiplicative change, if the amount that they're each multiplying by is different. So it can't work. So let's think about it from an additive viewpoint. So if we have now, and then in 5 years, and then 15 years after that, put Ben here and Vicki here again. So let's just think about it another way. I'm going to have the same numbers, but I want to think about it differently. So if right now Ben is 10 and Vicki is 40, in 5 years, if I add 5 to both of those, Ben is 15 and Vicki is 45. Is that what it told us up here? In 5 years, I'll be 45 and you'll be 15. It is. And then 15 years after that, adding an additional 15 years, we have 60, and 30. So even though we added 5 here and 15 here, we added 5 to both of their ages. We added 15 to both of their ages. So the additive works. So the additive reasoning works. The multiplicative, we did something different each time to go from the 10 to the 40, the 15 to the 45. So neither one of them are correct. Neither are correct. Okay, pause if you need to. Okay, this table shown represents the different statements between Vicky and Benjamin. Let V represent Vicky's age and BB represent Benjamin's age. So it says, today I'm 40 years old and you're 10. So if V equals 40 and B equals 10, they have the equation. Vicky said his age, 10 plus 30, equals hers. So in this comparison column, then how we are going to fill that out. Actually, we're just going to look at them first. Okay, so it says to complete the last column by identifying each relationship as either additive or multiplicative. Okay, so here I'm 4 times as old as you are, and we have same Vicky is 40, and Ben was 10 when it was the 4 times as old. Vicky equals the Ben's age times 4. Yeah, but in 5 years, I'll be 45 and you'll be 15. I feel like there's an error in this one. Let's go back up here. So this one is additive. And this one, it's multiplying. Remember, when a number and a variable sit right next to each other, it's multiplying. So that is multiplicative. So Ben's age being 15, 15 plus 30 does give us the 45. So that's additive. Then I'll only be 3 times as old. So 3 times. So we have multiplicative. And 15 years after that, I'll be 60 and you'll be 30. So we have his age, 30 plus 30. So adding. Then I'll only be twice as old as you, twice 2 times multiplicative. At any point in this age scenario, which relationship does not change? Every time when it's additive, we are adding 30 to Ben's age. The additive does not change. Is she always 30 years older than he is? So if we went back and looked at the other table, so when he was 10, she was 40. When 15, she was 45, 30, and 60. So 10 plus 30 gave us her 40. 15 plus 30 gave us her 45. 30 plus 30 meant she was 60. So the additive does not change. I think that might be the end of lesson 1. And it is. We're going to stop there.